Hello, this is lesson 9.1, Properties of Translations. Okay, lesson 9.1, our standards are I can define translations, I can understand properties of translations, and I can graph translations. These come from two different standards, Geometry Standard 1 and Geometry Standard 3. One says verify experimentally that properties of rotations, reflections, and translations. Lines are taken to lines and line segments to line segments of the same length. Angles are taken to angles of the same measure, and parallel lines are taken to parallel lines. And G3, describe the effect of dilations, translations, rotations, and reflections on two-dimensional figures using the coordinate graphing system. Okay, let me minimize myself here and let's begin. So, exploring translations. So, first of all, let's talk about what they are. So, you've learned about a function, right? You've been learning that a function is a rule that assigns exactly one output to each input. Well, a transformation is also a function. A transformation is a function that describes a change of a figure. The change of the figure can occur as a position change, as a size change, or as a shape change. Today we're going to be talking about position changes. So the input in a transformation is the pre-image, and the output is the image. So a translation, which is the focus of our type of transformation today, is a transformation in position. So let me illustrate that. I'm going to go under the dock camera to do a little bit of graphing. Okay, let's take a look at a translation. So we have a figure here, and we're going to give it some points. We're going to call this point A. We're going to call this point B, and we're going to call this point C. Now we can label the points. A has the coordinates 1, 11, 12, so 1, comma 12. B has the point 3, comma 7. And C has the point 1, comma 7. So where can I write that? 1, comma 7. Put it in there. Okay, so that is our pre-image. That's our input in our function. Now we want to do the image, which will be our output of our translation. Oops. So I am going to translate my figure, which happens to be a triangle, 7 units to the right and 5 units down. So I'm going to go 7 units to the right. And so I'm going to slide it. So remember, a translation is a slide. Translation is a slide. So 7 units to the right, 7 units right. And then I want to go 5 units down. This whole shape. So what I'm going to do is I'm going to take the point A and I'm going to go 7 units right and 5 units down. So since these all go up by 1 unit each, I'm going to just count. 1, 2, 3, 4, 5, 6, 7, and then 5 down. 1, 2, 3, 4, 5. So I'm actually going to get a different color here. Let's do green. Okay, that's my point A, my new point A, and they call that A prime. That's the symbol for a translation. Now, I have to do the same with C and B. So for B, I'm going to go 7 units to the right, 1, 2, 3, 4, 5, 6, 7, and then 5 units down, 1, 2, 3, 4, 5. Put my point there, that's B prime. And then I'm doing the same with C. 7 units right, 1, 2, 3, 4, 5, 6, 7, and 5 units down. 1, 2, 3, 4, 5. And that's C prime. then I can connect my points. I have just made a translation. My translation was a slide from here to there. So now what do we notice? We notice that the vertices of the image are labeled using the prime notation, which we have. And so A, notice that this vertice is the same vertice and in the same position, just in a different spot in the shape. So A stays A, right? If A went down here, that would be wrong, right? If C ended up here, that would be wrong. So we have to keep them in the same format for a translation. If it's a rotation, that's going to be a turn. So then A might end up upside down, right? But that's not what's happening now. Okay, so notice that when you have a translation, the orientation is going to stay the same. It's not going to turn, it's just going to slide. So it might slide sideways, it might slide down, it could slide up, it could slide left. There's all different ways it could slide, but it's not going to turn in a translation. Okay, let's look at some properties of translations. So I just was talking about one of them. So translations maintain the same length of their corresponding sides. So our triangle length stayed the same. Translations will maintain the same measure of their corresponding angles. Our angles stayed the same. And by corresponding, I mean A and A prime are the corresponding angles. Side AB and side A prime, B prime are the corresponding sides. Number 3, the sides that were parallel in the pre-image remain parallel in the image. We'll take a look at that in a minute. Translations preserve the size and the shape of a figure as well as its orientation. And that's the one I told you about. And a translation produces a figure that is congruent to the original figure. Congruent in geometry means that the figures have the same size and the same shape. Our initial triangle had the same size and the same shape as the ending triangle, the translated triangle. So now I'm going to go back under the document camera and show you some of the examples of some of these properties. Okay, here we have a trapezoid. 4 sides is a trapezoid, right? And with a trapezoid, we also know that 2 sides are parallel, the top and the bottom. So we are going to translate our trapezoid. This is trapezoid T-R-A-P, trap. Okay, so we are going to translate it. Let's see, we want to go 5 units to the left, 5 units left, and we also want to go 3 units up. 3 units up. So how we do this is we take each vertice. A vertex is a corner where 2 edges meet. These are the edges, the sides, 2 points where they meet, where the letters are, those are your vertices. Vertex is the one singular. Vertices is the plural of all of that. So let's start with T. And we are going to go 5 units left. 1, 2, 3, 4, 5. And 3 units up. 1, 2, 3. This is T prime. We're going to do the same for R. 5 units left. 1, 2, 3, 4, 5. And 3 units up. 1, 2, 3. That's R prime. A, 5 units left. 1, 2, 3, 4, 5. And 3 units up. 1, 2, 3. And that's going to be A prime. And finally P, 5 units left. 1, 2, 3, 4, 5. And 3 units up. 1, 2, 3. And that's P prime. And then we are going to connect the dots. Take my nice straight edge here. Notice how we are preserving the shape. And we are also going to be preserving everything else we've talked about. So let's see how that works. So let's start by measuring the lengths of the sides. So if I was to measure the blue side here, should I use this? Let's use these little doohickeys here. Well, maybe we can do it with this. So this is inches, right? So this doesn't start at the very edge of it, does it? Yeah, it does. So we have 1, 2, I can't tell. Let's use centimeters. It's easier to see. Okay, this is, looks like 2 centimeters. 2 centimeters in length. And then let's measure this. Notice how it's also 2 centimeters. Let's try the bottom. This is 2.5 centimeters. And this one is, I bet you can guess, 2.5 centimeters. And RA, segment RA or side RA is, let's see what we did on this one. Oh, that looks like 2.5 as well, or almost. Yeah, that's 2.5 centimeters. And this one is 2.5 centimeters. And in order to figure out the length of this one, mathematically, we could use the Pythagorean theorem, but we didn't learn that yet, but we are going to. So this one is also, it's like this length is, it looks like it's also 2.5 centimeters, and this one is 2.5. Maybe it's a little past that. I'm just going to go with that, okay? So, did you notice something? One of our properties is that corresponding sides maintain the same length. So, corresponding side RA corresponds to side R prime A prime, same length. Corresponding side TR has the same length as corresponding side T prime R prime. So each side length is the same length. Translation maintains the same side length. And what do you notice about the angles? Well, let's take our protractor here. Let's measure angle A. That should be an easy one, right? Angle A stops right here. You can tell that that says 90. That's exactly 90 degrees. So angle A, and I'll just write it here. Angle A is equal to 90 degrees. Let's see what angle A prime is equal to. Angle A prime, we put the little circle on the edge there and we line it up with our line and it hits right at 90 again. So angle A prime is equal to 90 degrees also. Let's do this angle here, angle P. So we put it on here and then we go to where the line meets. That is at, now we could use 110, but we're not going to, right? Because this is a acute angle. So this is going to be, well, we have to go the other direction with it, don't we? So let's just turn it the other way and do it this way. Can we do that? No, we can't. We have to do it this way. It's going to be the opposite of 110. So 180 minus 110 is 70, right? Yes, so this is 70 degrees. So this measure of angle P is equal to 70 degrees. Pretty sure, but I'm going to try this once. This one might work better. Yeah, it's 70. Okay, and then this angle P prime is going to also be 70 as well. I know it's on 110, but that's these numbers are the obtuse angle sizes. So this is 70 as well. Angle P prime is equal to 70 degrees. And I could do these other two angles, but you can tell that they are also going to be the same measures. So the corresponding angles have the same measures in a translation. The angles do not change. So what about the sides? We know that in a trapezoid, two sides are parallel, right? Can you tell which two sides are parallel? They're the sides that will never touch and will always be the same distance apart. So in this blue triangle, blue trapezoid, this and this side are parallel. They will always be the same distance apart. They will always be 2.5 centimeters apart forever and ever and ever and ever if we went into space. So TR and PA are parallel. And how we write that in geometry is side TR is parallel to side PA. Now we have to look at our translated trapezoid. Notice how TR prime and PA prime are also parallel. So TR prime is parallel to PA prime. Okay, so notice how another property of a translation is that the sides that were parallel in the pre-image, again, blue is our pre-image, our input. They will also be parallel in the image, our output. There is our image, and the same sides are parallel. Now these sides are not parallel, right? Because this one, if it was to go off into space, would eventually cross the other one. So those two sides are not parallel, which is the definition of a trapezoid, that only two sides are parallel. Okay, so what can we say again? Remember, translations are slides. And what do we know about them? They preserve the size and shape of the image. They preserve the size and shape of the image. They also preserve, we can see that, they also preserve the orientation. What do I mean by orientation? Orientation is how it's, if it's upright or left or right or up or down, you know. So like if it's turned, that's changing its orientation. So it's not turning the shape, it's only sliding the shape. The shape slid this way. So translations do not affect the rotation or the orientation, just the sliding. And you can also say that these two shapes are congruent. What does congruent mean? They have the same size sides and angles. So TR prime is congruent to TR regular. RA prime is congruent to RA regular. PA regular is congruent to PA prime. And TR or TP is prime is congruent to TP regular. And these little lines just mean that this 4 lines means it goes with this one, that they're the same size. And this line with 1 little tick mark means that they're the same size. And these have 2 tick marks, and these have 2 tick marks, so they're the same size. And these have 3 tick marks, and these have 3 tick marks, so they are the same size too. Okay, so that's how you kind of simulate it or show it in geometry. Okay, now I'm going to go back to the slides. I'll be with you in a second. Okay, so let's just go over this again. Properties of translations, they maintain the same length of their corresponding sides. They maintain the same measure of their corresponding angles. The sides that were parallel in the pre-image are also parallel in the image. Translations preserve the size and shape of a figure as well as its orientation. And a translation produces a figure that is congruent to the original figure. We just showed you all of that. So let's move on. To translate a figure in the coordinate plane, translate each of its vertices. And we've done that. A vertex is a corner where edges meet in a figure. Okay, I want to show you one more translation. Now we have a triangle here that's a little bit tilted, right? When we translate, we do not want to change the orientation. We don't want to turn it. We want to keep it leaning the same way that it's leaning. So this one is example 1 on page 281 of your book. It's figure XYZ. It's a triangle XYZ, triangle XYZ. And we want to graph the image of the triangle after a translation of 4 units right and 1 unit up. Okay, so we take each vertex, or all of the vertices, each one individually, and we do the corresponding translation with that vertice. So we're going to do X first. So we're going to move it 4 units to the right. Let me get my red one for our new translation. So since these are all 1 unit on the graph, we can do that. 4 units right, 1, 2, 3, 4, 1 unit up. That puts us right here with X prime. And you always want to, in geometry, to label everything. Very important. Y is 4 units right, 1, 2, 3, 4, and 1 unit up. That's Y prime. Notice how X and X prime, they're corresponding. Y and Y prime are corresponding. Z, do the same thing, 4 units right, 1, 2, 3, 4, and 1 unit up. And that's Z prime. And then we connect the dots. You're dealing with geometry and shapes, you're going to want a ruler. Notice how we have preserved the orientation, we have preserved the side length, we have preserved the size of the angles. All we did was slide our triangle. So that is how you're going to do graphing translations. In your homework, you're going to be getting to graph some translations, and I think you will enjoy this. So let me come back on here. Okay, so that's a little bit about translations, and your homework is going to be posted on Google Classroom. So have a great day. Bye.